Alright, let us look at another question related to heights and distances in the chapter Applications of Trigonometry. From a balloon vertically above a straight road, the angles of depression of two cars at an instant are found to be 45 degrees and 60 degrees. If the cars are 100 meters apart, find the height of the balloon. In order to understand what is being described, let me draw a rough sketch. So this is the ground level or the straight road, and let's just assume here is where the balloon is located. So the balloon's height over the ground is h, let's say, and let's assume this is the first car and this is the second car. So the angle of depressions are always taken with respect to the horizontal. So we'll draw a horizontal there. So this angle is the first angle of depression, and we'll see what that value will be. And this would be the angle of depression to the second car. So as you can notice, this angle is numerically smaller than this angle. So obviously the one which is pertaining to the car further away is going to be 45 degrees, while the angle of depression pertaining to the closer car is going to be 60 degrees. So once we get the angles of depression, we transfer it onto the ground level. So if you notice, since this is a horizontal and so is the ground, so these two angles are going to form a pair of alternate interior angles, and so would these two angles. So we'll transfer those angles. This becomes 60 degrees and this becomes 45 degrees. Now we are told the cars are 100 meters apart, which essentially means this distance is 100 meters. And let's say this is x. Now the stage is set for us to be able to involve tangents of 60 degrees and 45 degrees in order to form two equations and thereby find the value of h. Alright, now we have drawn a proper diagram, and let's call this height as h, which we are supposed to find out. So the tan of 60 degrees would be, now if you look at this triangle right here, we notice that tan is opposite, which is h, divided by adjacent x, h upon x, and we know tan 60 is root 3 h upon x. So therefore the first equation is h equals x root 3. Tan of 45 degrees would involve the larger triangle. If you observe, the opposite is h and the adjacent is x plus 100. So tan 45 would be h upon x plus 100. Tan 45 is 1, which essentially means x is x plus 100. Let's call this equation number 2. Since both equations are in terms of h, let us equate the right hand sides. X root 3 is equal to x plus 100. We bring the x terms together. X into root 3 minus 1 is equal to 100, which implies x is 100 over root 3 minus 1. Now one mistake which students often make is to try to divide 100 by root 3 minus 1. Root 3 minus 1 would be basically 1.732 minus 1, which is 0.732. Now dividing 100 by 0.732 is very difficult, and it is not advisable to do so. Rather, what we should be doing is we should multiply the irrational denominator by its conjugate and therefore eliminate the irrational part in the denominator. So we multiply both numerator and denominator with root 3 plus 1, giving us x is equal to 100 times root 3 plus 1 in the numerator, and the denominator becomes, this is a minus b into a plus b, so we're going to get root 3 whole squared minus 1 square, which is 3 minus 1, that is 2. So this is 2 here, cancels 50 times. So x becomes 50 times root 3 plus 1 meters. But we have been asked to find out h. We already know the relation between h and x, which is either we could do this or we could do this, doesn't matter, you get the same answer, but this seems a little easy, so we'll take h is equal to x root 3. Equation 1, h equals x root 3, which implies h is equal to 50 times root 3, root 3 plus 1. So if I multiply 50 root 3 into root 3, that would give me 150, and then plus 50 root 3. Now I'll leave this as it is, and I'll multiply 50 times 1.732, and I get 86.6 there. So this whole thing adds up to 236.6 meters, which is the height of the balloon. And that is your final answer.